as mentioned earlier, so my name is Mike Riggs. I'm a solution engineer also with Hortonworks. I work with Paul and Ron here. I'm based here in Dallas, local. I've been with Hortonworks for a little less than 6 months. Prior to that, I was at a company that had a big data platform that did Hadoop-based, and it was business analytics type stuff aimed more at the telecom type verticals. So I've got a couple, 3 years of experience, background in the big data / Hadoop space. So we've already talked a little bit this morning about like what can Hadoop do, and what cool problems can it solve, and what kind of neat stuff can we do with Hadoop. That's all the good, fun, exciting things. Now we get to the kind of a little bit more of the meat. Now, some of this meat's going to be a little dry, a little chewy. Bear with me. It's not the most exciting stuff in the world, but there's so many components in the ecosystem. So if you go out to the Apache's website and you look in the Apache website at all the projects that are around Hadoop, there are so many. It's hard to keep up with them at times. I'm only going to hit a few of the kind of bigger pieces. There's a lot more. Okay. I usually talk pretty loud, so can you guys? Are we good back in the back? Okay. So I'm going to talk a little bit about the kind of key pieces of the ecosystem here. So if you go to Apache's website and you start looking, there's a dizzying array of components that you need to put a Hadoop cluster together. And they have all these neat little, these neat little icons and stuff. But you start looking at these things and you think, well, which of these do I need? Do I need all these? Do I need some of them? What jobs do these things do? What are these components used for? I have these use cases I want to be able to solve. What are these pieces do I need to help solve these use cases? Now, before I get going here in the slides, so again, this is not exciting fun stuff. The slides will be available. You guys will get copies of them. So there's a lot of stuff on here to read. I'm not going to read just every piece of the slides, but you guys will get copies of the slides so that you can then refer to them later on and at least kind of get a handle on on some of the stuff. We're running kind of low on time, so we're going to go through this semi-quickly. So as Paul mentioned, when we talk about Hadoop stack, there's all these pieces. So we have to have, at a base level, HDFS is your distributed file system. At the base level, Hadoop is essentially HDFS and Yarn. These are kind of the two big pieces of it. But what happens is, what we found is over time, you set up a Hadoop project, and then as these things have matured, we find that if your IT team can't take care of the solution, if there's no things in place to make it enterprise ready, things like data governance and security and operations and management, if these pieces aren't in place, then you're going to have a bad time with your Hadoop cluster. Your operations guys are going to say, we can't take care of this, we don't know how to feed it, no. So in response to that, the open source community has kind of gathered together and built all these tools, this surrounding ecosystem that handles these type of requirements for data governance and integration, access, security, operations, maintenance, that sort of stuff. And we have here at a high level, and again, you guys are going to copy this because I know this is probably pretty hard to see back there towards the back. But at a high level, this is kind of where these pieces fit in. And we're going to kind of step through the majority of the bigger components, just to kind of get a feel for what do these things do, and what sort of functions do they provide. So we're going to start with, and this is it's going to be an ugly sort of picture if you've never kind of seen what a Hadoop system looks like. But we're going to start with the kind of overall big picture of what does a Apache Hadoop architecture, what does it look like? What's the system look like? We start with the basics down here. So this represents your sort of data lake grid. Data lake, I think either Ron or Paul mentioned this idea of being able to just put all your data in one place. That's what we refer to as data lake. At the lowest level, what we've got here is, this is your compute and storage. Yarn is manages the cluster. Compute and storage is essentially your, think of a couple of racks of just cheap little 1U pizza box type servers. Cheap, inexpensive, commodity hardware. That's essentially what these little boxes represent. This is where your compute is, this is where your storage is, this is where your memory is in these machines.
Could you talk a little bit more about Yarn when you get a chance?
Yes, we're going to do that. And again, so we're a little time constrained. We will be, the Hortonworks, the three of us will be here throughout the afternoon. So if we don't get to your questions now, hit us up later. Okay? So the first thing we want to do is we want to get data into our Hadoop system, right? So, I mean, it's pretty useless without some sort of data input. At a high level, your sources are typically going to be these different types of things. You got your social data, your clickstream data. We can bring in data from your existing EDW type infrastructures. We can bring in files. We can bring in log files. There's no end to the type of data that we can ingest into Hadoop. We have these 3 or 4 components here that we're going to talk a little bit about shortly that are responsible for basically doing the loading of data into the system. Once the data is in the system, we have a component called hcatalog that basically contains the metadata for the system. And again, if some of you guys are familiar with this sort of concepts, you guys that earlier said you're on that 7, 8, 9, 10 Hadoop level. I apologize for any redundancies here that you may be seeing. But so hcatalog basically maintains the metadata for what you're ingesting. You model apply the metadata, and then you want to pull your data processing tools in to start doing stuff to that data. There are a couple of kind of main data processing tools. We're going to talk a little bit more about them. But essentially, you run these tools on top of your cluster with the data already ingested, and this does your transformations, your aggregations, does your materializations. You can do your modeling, that sort of thing, using these type of tools. There's a batch schedule that runs on the system. Say, for example, you want to ingest data at a certain frequency, process it in some way, and then push it back out to your EDW every 6 hours. So there's a workflow schedule in there. It's called Uzi. These things have some interesting names. We'll get to those shortly. Uzi basically is responsible for the batch scheduling piece. It schedules and orchestrates your data. Falcon, data pipeline management. Somebody earlier, there was a question about data retention policies. I can't remember where that came from. But Falcon does that. Falcon is a piece where you can basically say, I need to store data in this cluster for 3 years. I need to store data in this cluster, this other type, for 6 months. Falcon can actually handle those types of data governance and retention type issues. Data management. Once we get all this good stuff, then we want to be able to extract that data, put it to your downstream sources, to your visualization tools, to your data scientist type of tools, whatever those your EDW, your OLTP. And this is basically where we do some materialization and exchange. So this is where we've done the processing, we've got the data kind of in a state where we want it, and a lot of times when we pull in this type of data, the streaming data, log file data, earlier there was talk of structured versus unstructured versus semi-structured data. Hadoop's very good at taking unstructured and semi-structured type data, doing some data cleansing on it, and putting it in a flavor that your existing EDW can understand. So that's one of the pretty cool use cases that we see for that. There's an interactive layer, basically is called PES, basically is responsible for the speed. But for example, I don't want to run batch queries. I don't want to throw a SQL query out there that's going to run overnight. I have something that I want to look at, like I want to put in a query and get results back in a matter of seconds. So this layer basically is responsible for that. And then from there we can dump data out to like your Excels, your Tableaus, whatever those querying and reporting tools are that you might be using. And that's basically for data visualization. We can also do stream time processing, real-time search, a lot of these type of functions. And Yarn, we're going to talk a little bit about Yarn later. Unfortunately, I don't have time to go into any great detail. But again, we'll be around the rest of the afternoon, so if you guys want to talk a little bit about this, hit us up and we can go into it. But essentially, Yarn provides resource management for the cluster, and it allows us to do things like this. We can run these different types of processes, these different type of processing engines, search engines, these types of things, they can all run resident in memory in your Hadoop cluster. We get a lot of this allows your applications to scale. One of our partners, SAS, we had a demo earlier this week where I don't know how many guys are familiar with SAS or what's called a SAS rack, which is essentially a rack of SAS hardware. They showed us a query that took about 8 hours to run in a SAS rack. When they ran it in memory in a Hadoop cluster, that query time dropped down to less than 10 minutes. So it scales very, very well, very, very scalable. And then securing the whole thing, I think there was a couple of questions about security as well earlier. We have a couple different things. We have Knox, which is a perimeter level security. Knox is basically a gateway to the entire cluster. And what it's responsible for is REST type API calls, HTTP calls, things of that nature into the cluster. This way, your end user audience only has to know one place to go. They basically point their tool at that Knox gateway, and the Knox gateway is responsible for distributing the queries within the cluster. So this way, you don't allow your end users or your BI guys direct access to the cluster. So we're going to talk. This is where it gets a little cheating. These acronyms. What all these things do? What are they? So HDFS is Hadoop Distributed File System, and I was in a meeting yesterday with Harley Davidson Financial Services. Same acronym, and they kept saying HDFS, and we kept saying HDFS, and it was oh, hang on, guys, what are we talking about here? It got a little confusing. HDFS is essentially the distributed layer for the storage piece. So you've got your racks of one-use servers. HDFS is the mechanism that basically distributes your data across all those servers, across all those disks in that cluster. Essentially what it does is it's responsible, it'll write triplicate copies of the data. There's a master node that basically knows where that data is. The worker nodes basically phone home at regular intervals, and when the master at a very high level says, wait a minute, this worker's dead, I got to reallocate his resources somewhere else. And that's how you maintain your data integrity. That's how you don't lose data. Hadoop is basically, HDFS is very tolerant of equipment failures. It's actually designed with equipment failures in mind. As some of our, Paul talked earlier about our solutions being tested at scale at Yahoo. We had a kind of a fun talk with the Yahoo guys a while back. There is a team at Yahoo that is responsible for doing nothing more than going through the data center and swapping out hard drives in their Hadoop clusters. So Yahoo has about 32,000 nodes. As you might imagine, disks are going to be failing fairly frequently. And they have a guy who has literally a shopping basket full of hard drives who just goes up and down the rows looking for the little light that says there's a drive out in this machine, and he spends his whole days swapping drives. But Hadoop is very, very tolerant of that type of stuff. Yarn is yet another resource negotiator. Yarn basically is responsible for managing the cluster. So Yarn is responsible for making sure that processes don't spin out of control, take all the memory of the cluster down. It's responsible for making sure that each process gets allocated adequate disk space, CPU power, memory. It's essentially the operating system of the cluster. Back up. And this is kind of the two big sort of pillars that the rest of the ecosystem is kind of built on. On those, we can run multiple different types of data processing engines. So way back when, MapReduce version 1, there was one processing engine, that was MapReduce. MapReduce was also responsible for managing the cluster resources. So Yarn basically segregates that out, splits out the cluster resource management piece, and then leaves MapReduce on its own as just a processing engine. It doesn't do anything other than that. MapReduce in and of itself is mostly built for batch processing. That's its main kind of purpose for being. Tez is a SQL engine. Well, it's mostly a SQL engine. Basically, it generates directed acyclic graphs, DAGs, which I'm not going to go into all that. Essentially, what it does is it eliminates a lot of the bottleneck, a lot of the I/O. So MapReduce, the functionality of TEZ is similar-ish to MapReduce. MapReduce has these intermediate stages where it will go out and write data to disk, and then pull it back off disk, bring it to the next stage, do its processing, write it to disk, pull it back. There's a lot of disk I/O involved in any sort of MapReduce operation. TEZ basically kind of closes all that stuff down, collapses a lot of that, keeps it all in memory, and these type of operations run much, much faster. Typically, we see TEZ, we see in conjunction with Hive. We run Hive on top of TEZ, so it gives you a very high-speed SQL engine. I'm going to talk about Hive here shortly. Spark. Spark is basically an open source. It's designed for analytics. Spark's coolest thing that it does is it'll keep data in memory, and you can iterate through it multiple times without ever writing it to disk. Spark is excellent for things like machine learning. So if you've got an application that needs to iterate through a huge data set multiple times to get to a machine learning algorithm, or while you're training or modeling machine, Spark is great for that. Solar is a search engine. It's built by Apache. Essentially, we can do full text searching. We can do database integration. We can do rich document handling, and it basically does distributed search and replication. Data access. So we talk about the data access layer. These are the things that your data worker guys typically spend most of their time working with. How are we looking on time? Are we mostly okay?
11:21.
Okay. And what time? How long do I have to?
I have to check.
Okay. No, I'm just kidding. I don't want
I'll find it then.
I don't want to run out of time. And so what time?
10 minutes more.
Okay. Perfect. Thanks. So when we look at data access, so you got all your data. Your data's in Hadoop. Now you want to access it. You want to do stuff with it. You want to create queries. You want to manhandle and massage that data. And so we've got these different types of tools. So Pig is a scripting language, and if you've ever written any basic like Perl, Python, VB scripts, those type of things, Pig will look very, very familiar to you. It's basically a kind of a high-level scripting language. Hive is your SQL interface. So Hive basically, if you want to sit down, you have SQL commands that you're running against, your SQL database, whatever. Those commands you can run in Hive. Hive is basically your SQL layer into Hadoop. HCatalog, as I said earlier, basically it's a table and storage. It's the management layer. It maintains the metadata. The cool thing about this is you can put all your data in one file system in one place in HDFS. HCatalog maintains the metadata for that data, and then it's all these other tools, Pig and Hive and these other guys, have access to that data, and the metadata basically allows all those tools to see the same metadata stored in one place. So you don't have to have a set of metadata for your Hive function or for your Pig functions or whatever. HCatalog basically is your central repository for that. All these other tools that kind of look on top of that can access that data directly, and so that way you don't have to worry. You can change your schema, your metadata in one place, and all these tools can then access it afterwards. HBase is basically a NoSQL database. It sits in memory, very, very high speed NoSQL processing. So if you've got some NoSQL type use cases that you want to be able to run on your HDP, on your Hadoop cluster, HBase is your man. Accumulo is another NoSQL database.
Quick question.
Yep.
So just trying to understand a situation where we would need to have both HBase and HCatalog. Because one is saying that we can, store it and use it in a non-relational format. The other one is relational. So if you can work with non-relational and manage it that way, why would you also want a relational view of that?
Okay, so again, it depends on the use case. So it depends very, very tightly on the use case, really. There's ways we can look at this a couple different ways. But don't think of HCatalog really. Think of HCatalog as more of like a metadata manager. It does some other stuff, but its main function is to manage that metadata. So that's its kind of main claim to fame. whereas HBase and Cumulo are more of those traditional type NoSQL things. So when we talk about relational versus non-relational, don't really think of HCatalog as that. It has some of that functionality, but its main use is for metadata storage. That makes sense. Cumulo is another NoSQL database. Basically, Cumulo is based on Google's Big Table. It has, its main thing is that it's very tightly secure. So when we talk to guys in the government, and we talk to those nice three-letter agencies everybody's so fond of, Cumulo is one of those things that they're very interested in because it's got a very tight security layer. It's granular all the way down to the cell. So we can control access to the data all the way down to the cell level with Cumulo. Pretty cool. Basically, in this, Phoenix is basically a SQL skin that rides on top of HBase. Basically provides you an embedded JDBC driver so that you can then use low latency queries over HBase. The difference is here. You'd use Hive for more of your batch type things. Hive on MapReduce is very suitable for batch type processing. Hive running on Tez is a little more interactive, so you get your response times back in like a few seconds. Whereas these guys, Phoenix, sitting on top of HBase, will drive those type of queries even faster because this all is all in memory stuff. Data governance and integration. And again, we're going to go through kind of these kind of quick. Falcon, so there's multiple ways to get data into your Hadoop cluster. Falcon basically is data governance, pipelines. We can do these retention policies, things of that nature with Falcon. Scoop is purely a SQL ingestion engine. So basically you point Scoop at your existing SQL server and it'll ingest whatever SQL data, whatever tables you pointed at. Flume is designed primarily to collect log files. Log Flume, I didn't even realize that until way too late, so I don't want to. Storm does data streaming. So if you've got a lot of these, Paul earlier talked about some of these use cases where you've got streaming sensor data coming in. Storm is perfect for that type of stuff. Storm, we can build bolts topologies, and I want to talk to that very briefly, that will allow you to do some sort of data transformation and processing prior to landing that data within the file system. Security, we have two main security components. I talked about Knox earlier. That's the perimeter piece. Ranger is what Paul was talking about earlier. We bought XA Secure, basically took their technology, open sourced it, and now it's actually an Apache project called Ranger. Ranger is essentially for more granular type security. It's for more of a authentication, authorization, accounting type of mechanism. We've got three more little guys here to talk about. So this is your operations management layer here. Zookeeper basically is distributed, and you can keep all your configs and stuff in Zookeeper. So Zookeeper, and it does a couple other three things, but its main thing is that. I talked a little bit earlier about Uzi, job scheduler. Ambari, Paul talked a little bit about this, is your cluster management. Basically, it's a one window pane into being able to manage the entire cluster, and it doesn't matter if you got 50, 100, 1,000, whatever nodes. You can manage all that in Ambari in one centralized place. It's pretty slick. And you guys, I think during the workshops later on, we'll get to take a look and play with a lot of these things. Hue is a web interface designed for like the data worker guys. So if you're the BI guy, you're the data worker person. Hue's an interface that allows you to go look at. It's just a nice web interface. Most people use it for Hive and for Pig. All right. One thing that always comes up. Which of these guys do I use? So there's usually not any questions surrounding how do I get data out of the system, because I'm going to dump it to my SQL database. I'm going to look at it with Tableau. I'm going to query it with Excel. Most people, that's easy piece. There's all these different methods to get data in. Well, what do we use each one for? And this is going to be, I got just a minute or two. Flume, I mentioned earlier, log files. This is essentially what Flume looks like. You collect this is your web servers, your syslogs. They basically dump to a Flume collector. Flume has sinks, which basically determine where that data goes once Flume has collected it. So we can have multiple sinks for the different collectors. We can basically have a search sink that dumps their data into a search tool, and we can have like an HDFS sink that'll dump data into Hadoop. That's Flume. Storm. Storm's kind of cool. Storm's actually very cool. We build these topologies, Storm topology. Typically used for storm, as I mentioned earlier, is stream processing. The cool thing is we basically ingest the data from a spout, but then we can run it through all these bolts. And a bolt basically is a function that does some sort of pre-processing with that data stream before it actually hits HDFS. And again, you guys will have the slides, you can read through this, but basically this talks about what each bolt does. And you can feed data through multiple bolts and do multiple things with it before you actually get it to where it's going to go. Falcon, its main use, as I mentioned earlier, is for data governance, replication, and lifecycle management. Falcon, basically, you generate a data pipeline and you tell Falcon, within this data pipeline, these data types need to be stored in this cluster for this long. These data types go over there and they're stored for this long. You can create all your retention policies. You can do governance. Who was the last person? Who was the last entity that's touched this data? Where did it come from? What's its source? Where's it going? Spark. Iterative and memory learning. Okay, and I'm being told I'm done. Anyways, Spark basically streaming and memory, iterative machine learning. I would say, anybody have any questions? But I don't have time. But as I said earlier, hold on. Yeah, I've already said that too. We will be here throughout the afternoon, so I know there's a lot of stuff to go through very quickly. But please feel free to grab us and ask questions. We'll be happy to help you guys out.
Eso,